Hi Year 12s, we've already talked about how the ocean is absorbing carbon dioxide and that this is resulting in ocean acidification due to the production of carbonic acid, and also that this ocean's acidification is decreasing the amount of carbonate ions which are present, which are needed by marine organisms for their skeletons. Today we're going to talk about how the ocean is absorbing carbon dioxide again, but this time we're going to reflect on that this is a good thing. Okay, the ocean is in fact absorbing something like 22 million tons of carbon dioxide a day, and this represents around about a quarter, 25% of the carbon dioxide that we produce is going straight into the ocean. So it is being absorbed like this into the ocean, and it's undergoing this reaction, reacting with water and forming carbonic acid, and therefore staying in the ocean. Not always staying in the ocean. Sometimes carbon dioxide is also degassing from the ocean, so coming out of solution back into the atmosphere from surface waters. And you might recall the lemonade experiment that we did. Of course, you've all drunk lemonade before, and lemonade has bubbles of gas in it, which are there when it's low temperature and high pressure. So think about that lemonade. When there's low temperature and high pressure, the carbon dioxide stays dissolved in the lemonade. When you increase the temperature, and when you release the pressure by opening the top of the bottle, the carbon dioxide then leaves the solution. Okay, so this is an equilibrium. We've got carbon dioxide going into the ocean, carbon dioxide leaving the ocean in equilibrium. One way that this degassing or going back into the atmosphere is prevented is by these dissolved carbon dioxide moving into the deeper oceans. Okay, and that can happen in a couple of different ways. One is just by the movement of water, so a physical means. Okay, so physically, so we'll call this a physical part, shall we? The waters are moving due to downwellings, due to the thermohaline circulation, you recall from last year. And if this carbon dioxide is captured in the deeper waters, which have low pressure, low temperature, they're cold, and high pressure because they are much deeper, then the carbon dioxide can be stored there for much longer. I hope that you've heard this word before, sequestration. So because we say that the carbon dioxide is sequestered in those deeper layers of the ocean, so it's stored there. Another way that carbon dioxide can be stored for longer periods of time in the ocean is due to biological means. So we might call this the biological pump. And the first biological, there's two things I want to talk to you about. One is photosynthesis. And you all know that the equation for photosynthesis will change to green because, of course, it's what we're after, isn't it? Oh, it's not green. Is the reaction between carbon dioxide and water making glucose and oxygen. And this is done by producers. So this is done by phytoplankton, by algae, and so on, wherever there is light. So this has to take place in the surface ocean because it needs light to occur. But after it is there present as glucose or other organic compounds, so we'll just use a more general word, carbohydrates, or you might see it just written as organic compounds. So organic compounds just means the compounds used by living organisms. Once it's present as these carbohydrates or organic compounds, It can fall as marine snow. Okay? And marine snow sounds lovely, but really it's made up of dead organisms and fecal matter. So it's not quite as charming as it sounds, but it is actually vitally important for the food chains which occur in deeper waters. So the deeper water organisms relying on this marine snow as their source of organic material. And it also enables the material to fall and go into the deeper ocean, and so carbon is stored for longer. The other biological means that I wanted to talk to you about is that it is stored as calcium carbonate. How could I forget? Okay, so calcium carbonate, mostly from phytoplankton. Okay, so there's some phytoplankton such as coccolithophores, you might hear about those, which have a calcium carbonate shell around the outside of them. They're tiny, they've got a little armor of calcium carbonate. These phytoplankton are super abundant in the ocean, and so they're using a lot of that carbonate. A lot of the carbon is taken into their calcium carbonate skeletons, and again that calcium carbonate is falling as marine snow. So that's calcium carbonate and organic matter falling as marine snow and making its way into the deeper ocean where it's sequestered because it can no longer degas into the atmosphere. All right, we'll have a think about a couple of things which affect how much carbon dioxide is being absorbed by the ocean. The first thing I want to talk to you about is heat. All right, so you hopefully remember again from our lemonade experiment that hot water dissolves less gas. So hot water found perhaps near the equator that was a lot of effort to write one word, wasn't it? Hot water found at the equator is going to dissolve less gas. So at the equator, there's going to be more gas coming out and just a little bit of gas going in. Think about at the poles, the opposite is going to happen. So at the poles, there's going to be more carbon dioxide going in and just a little bit of carbon dioxide going out because cold water dissolves more gas. Another thing which will affect the amount of carbon dioxide dissolved in the ocean is the amount of photosynthesis that's occurring. So if there is more photosynthesis, there will be more carbon dioxide dissolved. Okay, or stored probably is a better word. Okay, so this biological pump, if there's more photosynthesis, the biological pump is going to be using more carbon dioxide and therefore storing more carbon dioxide. So another thing I want you to think about is climate change. So as the ocean gets warmer, it's going to dissolve less gas, which means that there'll be more carbon dioxide in the atmosphere, which means that there's now got a positive feedback loop, so it will mean that the temperature gets hotter again. Another thing which could happen with climate change is there could be a strengthened thermocline. Okay, so here I've got a diagram showing the marine snow is falling, remember, made up of organic material and calcium carbonate. In order for it to be stored or sequestered longer, it needs to be able to pass through the thermocline into the deeper oceans. But if we've got a strong thermocline, a very distinct layer, it stops the circulation of the vertical circulation of water. And so the marine snow tends to accumulate here and be consumed by organisms here instead of making it down through into the sediment and stored in the deeper oceans or on the sea floor. Okay, Year 12, the last thing I want to talk to you about is the CCD, or the carbonate compensation depth. And this is where we're talking about calcium carbonate, for instance, from phytoplankton, which is formed close to the surface where there's light, and then it falls to the ocean floor, and if the conditions are right, it forms a calcareous sediment. So calcium carbonate gets deposited on the sea floor when the conditions are right. And when I mean the conditions are right, I mean that the calcium carbonate dissolves when there's a high acid conditions. What conditions contribute to high acid is the presence of carbon dioxide. And we know that carbon dioxide is dissolved more readily when there's high pressure. We know that it's dissolved more readily when it's low temperature. And both of these, high pressure and low temperature, are happening in the deep ocean. So the deep ocean is more acidic than the surface ocean. And there's a layer, this is where we're going to talk about a certain depth, and I'll just draw a line across here. So that's just an imaginary line that I've drawn. When at this depth it is more acid, and so the calcium carbonate is dissolving. So there is no calcium carbonate sediment on these deep levels. But you can see that when it is in shallower water, this black stuff, this black drawing here, represents calcium carbonate is forming a layer on the ocean floor when it's at a certain depth. So we call this line the CCD. It's the carbonate compensation depth. So it's the depth below which calcium carbonate is dissolving faster than it is settling. And here above the CCD, the calcium carbonate is settling at a faster rate than it is dissolving.